Hello, Dr. Yohe. This is business statistics, quantitative methods, excuse me, for Huntington. And today we're going to work through some problems that are similar to the ones that have been assigned to you on your homework. To save time, so I'm not writing this stuff down, I am using an answer key here. We're not working the exact problems, we're working ones that are similar to them. Okay, so this is very similar here to 9.7, it's 9.8. And they give you, let me go up to the question here. There we go. Equation for a straight line y is determined b sub naught plus b1 times x. Okay, and this is a deterministic model. Okay, now they say that if this line passes through 1, 1, okay, then 1 is equal to beta naught, that is your y-intercept, plus beta 1 times 1 minus 1. Okay, this is the slope of the line for a linear relationship. Okay, this is a very simple regression model. We'll get more complex later, but this is a univariate model. Okay, so here we have 1 is equal to this. We subtract 1, and we're going to get equals beta 0 plus beta 1. Okay, likewise, we have a line that passes, the same line passes through 5, 5. So we set that up. Okay, and we can solve. We've got 1, I don't know why this negative is here. 1 is equal to beta 0 plus beta 1. Okay, and we have this other equation, 5 is equal to beta 0 plus beta 1 times 5. So here we can subtract, in this case, the second equation from the first, and we can solve for beta 1. So here we've got negative 4, beta 0 minus beta 0 is 0, is equal to beta 1, that was times 1, minus beta 1 times 5. Okay, so 5 times beta 1. So that leaves us with negative 4 is equal to negative 4 times beta 1. Divide both sides by negative 4, we get, and switch them around, we get beta 1 equals 1. So that the slope of this regression line, beta 0 plus beta 1 times x, the slope of that, beta 1, is 1. Once we have that, we can stick that 1 into any one of the equations, and we chose the first one here. Okay, 1 is equal to beta 0 plus beta 1 times 1. We stick that 1 in there. I got 1 is equal to beta 0 plus 1. Therefore, we subtract 1 from both sides, and I've got beta 0 is equal to 0. So the equation is y is equal to 0 plus 1x. The slope, the y-intercept is 0. The slope is 1 times x. So y equals x would be the deterministic equation for our regression. Okay. Part B here. The equation for a straight line is y is equal to beta 0 plus beta 1 times x. And then they're going to give us 2 points that the line passes through. Okay. The first line passes through 0, 3. So we stick a 0 in for x, the 3 in for y, and I've got 3 is equal to beta 0 plus beta 1 times 0. This is 0. So here we've already solved for beta naught. That is the y-intercept. This crosses the y-axis at 3, and that's very easy to figure out because 0, 3, x is 0, y is 3. So that is our y-intercept. Now we need to get the slope of the line. Okay, and there's a number of ways to do that, but here we are going to put 0 is equal to beta naught, that's the y-intercept, plus 3 times beta 1. We get that from this second equation here where we say that the line, we get this from the second point where we are told that this line passes through x equals 3, y equals 0. So I stick 0 in for y into this y equals beta naught plus beta 1x equation. I stick 0 in for y from this point that it passes through. I have beta naught plus 3 times beta 1. Okay? Or negative beta 0. We subtracted a beta 0 from both sides. Beta 0 is equal to 3 times beta 1. Now we know that beta 0, beta naught, is equal to 3. We solved for that up here. So we stick a 3 in for beta naught, and we get negative 3 is equal to 3 times beta 1. Divide both sides by 3, and we're going to get, and switch them around, we got beta 1 is equal to negative 1. Therefore, the line passing through 0, 3 and 3, 0 is y equals, we need beta naught, we solved that as 3, we put 3 in there. We need beta 1, we know that that's negative 1, we just solved for that. So negative 1 times x, that's the same as negative x, right? Negative 1 times any number is the opposite of it, the negative. Okay. Part C here, the equation for a straight line is y equals to beta 0 plus beta 1 times x. That is going to be the basic model for your deterministic model when we have a linear relationship with one variable, x1, or x, excuse me, x, we don't need to specify. X's are, there's a linear relationship between x and y. Now, if the line passes through negative 1, negative 1, okay, then we know that we can substitute this into this general equation here. So y is 1. I put that in for y. 1 is equal to, I don't have any information on beta naught, so I leave it there, plus beta 1, the slope coefficient, times negative 1. I substitute a negative 1 in there for x, because this line passes through x equals negative 1, 1, and I'm just substituting in for x and y initially. Once I've done that, okay, they tell us that this likewise passes through the point 4, 2. So we take this same general equation here, substitute a 2 in for y, equal to beta naught plus beta 1, and then here we know this point, this line passes through a point where x equals 4. So we stick the 4 in there. Now all we do is we take these two equations that we just got from substituting in x and y, we didn't do anything else, and we subtract one from the other. Okay, you'll remember this from algebra, I hope. So the first equation I've got, I stuck this one up at the top. 2 is equal to beta naught plus beta 1 times 4. This is the equation when the line passes through x equals 4, y equals 2. Then I'm going to subtract this first equation. It doesn't matter which order you pick them in. Okay. So here I got to subtract this equation. So I'm going to multiply everything times negative 1. So I've got negative 1 times 1 equals beta 0 plus beta 1 times 1. Because that line passes through the point x equals negative 1, y equals 1. So 2 minus 1 is 1. Beta naught minus beta naught is 0. I've got beta 1 times 4, okay, minus a negative, right? So we know that turns into a positive. So a positive and a positive we're adding here. I've got 5 beta 1. So 1 is equal to 5 times beta 1. We divide both sides by 5 to isolate the beta 1, and I get beta 1 equals 1 over 5. So now I know the slope coefficient. I know beta 1. I know x. I know y for any of the 2 points that we looked at. So all I need to do is solve for beta naught, the y-intercept. So we took this equation here. 1 is equal to beta naught plus 1 over 5. I substituted the 1 over 5 that we just solved for in for beta 1. Okay, times -1, because we know that that point passes through x equals -1, y equals 1. So all we did is substitute in things that we know. This is what we don't know. Okay? So we can now solve for beta naught, b sub naught. And if we were to do that, we would say, okay, we've got 1 equals beta naught minus 1/5, multiplying those two together here. Okay, then we know that we need to isolate beta naught, so we can divide both sides by, excuse me, I'm sorry, we're going to add 1/5 to both sides. We're going to get rid of this 1/5. And that's going to leave us with beta naught equals 6/5. And then we know beta 1 is 1/5. So this would be the equation for that. This would be the regression equation for that particular relationship. Y is equal to 6/5. That's my beta naught. We solved for that here. Plus beta 1, we solved as 1/5 here, times x. That's the equation for that regression line. That line describes the relationship between x and y. In this case, these are deterministic relationships. There is no error term. Okay. Finally, part D here, the equation for a straight line is always the same. This doesn't change. Y is equal to beta naught plus beta 1 times x when you have this deterministic relationship. If the line passes through -6, -3, okay, we substitute -3 in for y. -3 is equal to beta naught, we don't know that, times beta minus beta 1 times 6. Here I took that -6, multiplied it through. So it could be plus beta 1 times -6. Here we just went an additional step and made that a minus sign and got rid of the negative on the 6. Okay. Then we know that it passes through a second point where x is 2, y is 6. Stick 6 in for y, equal to beta naught plus beta 1. We have no information on those, so we can't change them, times 2, because we know that at this point, the line passes through x equals 2, y equals 6. So then we take these equations and we subtract one from the other. We chose to subtract this one from the second. So I have 6 equals beta naught plus beta 1 times 2. Then I'm going to subtract this whole equation here. -3 is equal to beta naught minus beta 1 times 6. Okay. When we distribute this negative sign through, that becomes a +3. 6 plus 3 is 9. This is a positive beta, that's a negative beta. We add across, you get 0. And then I've got beta 1 times 2 minus beta 1 times 6. But I've got to take that negative, so this becomes a positive, and we add them. So that becomes 8 times beta 1. So 9 is equal to 8 times beta 1. We then divide both sides for 8 to solve for beta 1 and flip them around, right? You can't see, I'm trying to get you. We flip the equation around just so beta 1's first, that just make it look nice. Beta 1 is equal to 9/8, because we divided both sides by 8 here. So once we've got that, we can stick this beta 1 into the equation for either point. And here we chose to stick that in for the point where x equals 2, y equals 6. And I've got 6 is equal to beta naught plus 2. That's the x value times the beta 1 coefficient. These should really be flipped around again, right? The beta 1 should be the first number you see, and then the beta 2, but we flipped them. Okay. We stick that in, we solve for beta 0. 6 is equal to -18/8. Okay. Plus beta naught. Subtract 18/8 from each side, and I get beta naught is equal to 30/8. Okay. This would be, when we bring this negative 18 over 8, we're adding it to that. Or I'm sorry, we're subtracting it from 6. 6, if we convert that into eighths, would be 48 over 8. So I have 48 over 8 minus 18 over 8. That comes out to be 30 over 8. So we stick beta naught in the value for beta naught into the original equation that you always start with and always come back with. So y is equal to 30 over 8. Okay. And this is equal sign here, but that should be plus 9 over 8 times x. So let's just say that x was 3. We'd have 30 over, let's make it easy. Let's just make it 8. Okay. So here we'd have 30 over 8 plus 9 times 8 is 72 over 8. That would be 102 over 8. And we'd simplify that, and that would be the value for y when x equals 8. Okay. Now the nice thing about these equations is, if they're accurate, that we could use this equation. If we're given any value of x, we could predict what the value of y is. Okay, which is what I did when I said let's assume x is 8. X is 8. That gives us 30 plus 72 over 8. That's 102 over 8. We can simplify that. We can divide both sides by the top and bottom by 2 and get 51 over 4, and then convert that from a fraction to a mixed number and have the correct answer for y. Okay, that's 9.8. This is very similar to what you're doing in 9.7. Thank you, and I'll try and make a couple more videos while I've got the time.